Welcome back to my channel, guys. Today I'm teaching you dative covalent bond, which is a type of a covalent bond. Actually, this is an extension of a covalent bonding. Okay, let's see. First, a covalent bond is formed between two non-metal. We know that. And how it is formed, I have discussed this in my previous video. Anyone? How a covalent bond is formed? It is formed by simple sharing a pair of electrons between two non-metal. We can say a mutual sharing. So this is an extension of a dative covalent. This is an extension of a covalent bond. Okay, first of all, see what is meant by the term dative covalent bond. Yeah, see, dative covalent bond, which is also called as a coordinate covalent bond. It is a type of covalent bond. It is a type of covalent bond in which shared pair of electrons are provided by one of bonded atoms only. So we didn't get it. In case of the covalent bond, sharing of an electron takes place between two non-metal. It is a type of the covalent bond in which the shared pair of the electron provided by only one atom having lone pair. Lone pair of electron which do not participate in chemical bonding. That will help to make a dative bond. Okay, guys. Let's see some example of dative covalent bond. We have two examples: hydronium ion and ammonium ion. Let's do the first example of ammonium ion. How a dative covalent bond written? Look, A arrow B. It means A having a covalent bond with B and donate a pair of electron to B. B, after making a covalent bond, A is left with lone pair of the electron and A donated a pair of electron to B. Here B is electron deficient. This arrow represent movement of electron or donation of electron from A to B. A donate a pair of electron to B. Okay, A contain lone pair of electron. Look at the example of ammonia and ammonium ion. Look at that one. Ammonia, you know that ammonia is a covalent compound because nitrogen has 3 electron share with 3 hydrogen atom and nitrogen left with a pair of electron. Okay, when an acid dissolve in water, it gives away H plus ion. This is the property of an acid. So all the acids which gives away H plus ion, that is proton, in water when dissolved in water. So we have H plus ion. This H plus ion has no electron. It has only one proton. Hydrogen has one electron and one proton, but that H plus ion has no electron, lost the electron. It gives away the electron. Now, nitrogen, after making 3 bonds, still has 5 electrons. It still has a lone pair left on the nitrogen. Nitrogen is from group 5 element. It can easily make 3 covalent bond. Along with that, it has one lone pair left. That lone pair donated to H plus ion to make a dative bond. See how we write the dative bond? Look at that. Nitrogen already has 3 hydrogen atom and one more bond which is called a dative bond to the hydrogen atom. This hydrogen atom has no electron. That electron donated by nitrogen. So it is a one-side donation. In some books, it is written as back donation. So it is a type of back donation. So this 2 electron come from nitrogen. It's a sharing, but sharing by only one of the bonded atoms. So look at that. I missed something. Look at that. What I miss? Any guesses? Nitrogen can make 1, 2, 3 bond. Here nitrogen made 4 bond. 1, 2, 3, 4. Nitrogen has trivalent. It can make only 3 bond. If it is giving away a pair of electrons to make a dative bond, we have to write a positive charge, overall positive charge on the nitrogen, because nitrogen lost a pair of electrons towards hydrogen, and this is called ammonium ion. When we have a suffix called em, meaning a positive charge ion, ammonium. So I've seen many past paper questions in that they ask draw a dot and cross structure of ammonium ion. So ammonium, in case of ammonium ion, nitrogen make a dative bond with H plus ion. Look at that one more example. First, I want to draw the dot and cross structure of ammonium ion. Okay, this arrow show donation of electron from nitrogen to hydrogen. I will give you one more example, like hydronium ion. Let's draw the dot and cross structure of ammonium ion. 2 mark, or I never see 3 marker in that, mostly 1 mark. Or if they will ask draw a dot and cross structure of ammonium ion, that could be a 3 marker. Dot and cross structure of ammonium ion, NH4 plus. Like first start with the ammonia, dot and cross structure of ammonia. Central atom is nitrogen. Nitrogen has 1 electron, 1 electron, and 1 electron. Each share 1 electron with hydrogen. That's from the hydrogen. 1 electron and electron from the hydrogen. 1 electron and 1 electron from the hydrogen. Nitrogen has 2 electrons which are shared with hydrogen atom. So this is a dot and cross structure of ammonium ion. You have to focus on these 2 dots. These 2 dots mean that 2 electron donated by nitrogen. One more example of hydronium ion. Hydronium ion. Whenever we end up with em, like a suffix em, meaning a positive ion, and they have a dative bond. Just now I told you, acid when dissolved in water, it gives away H plus ion. Any acid like HCl, HNO3, nitric acid, sulfuric acid, all the acids, hydrochloric acid, nitric acid or nitric acid, sulfuric acid, all these acids when dissolved in water, it gives away H plus ion. So that H plus ion come from acid, and this H plus ion has no electron. Now look at the water, like we have H2O, 2 electron with nitrogen, oh sorry, oxygen has, let me draw in different way, like this is oxygen, 1 electron with hydrogen, 1 electron with hydrogen. So this is hydrogen, this is oxygen. So oxygen has total 6 electron, 1 electron and share with hydrogen, 1 electron and 1 share with hydrogen. It left with 2 lone pair. That lone pair take part in making a dative bond. Not both the lone pair, just one lone pair, guys. We do not have like H4O. That's not possible. We have H2O and 2 lone pair. Either of that lone pair donated to H plus to make a dative bond. Now, oxygen donated a pair of electron to this hydrogen and form a dative bond and make a dative bond. Look at that. Look at the dative bond. Oxygen, 1 hydrogen here, normal covalent bond, 1 more hydrogen. This hydrogen has a positive charge before that, and now it gained 2 electron from this oxygen. Always positive ion, you have to put a plus charge here. So this arrow represent a dative bond, and the head shows you a pair of electron donated by oxygen. So that's the direction, oxygen to hydrogen. What's the name of this ion? Hydronium. Hydronium ion. Okay. Now that's the let's draw the dot and cross structure of hydronium ion, which is easy. Before that, it has 2 covalent bond. Oxygen atom has 1 covalent with hydrogen, 1 covalent with 1 more hydrogen. Here, I want to draw here. This oxygen, 1 covalent with hydrogen, 1 more covalent with hydrogen, 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 a covalent bond, 1 more covalent bond, and a dative bond. Dative bonding, this dative bond, a bond shared formed by a shared pair of electron only from oxygen. This is the oxygen. When we deal with the transition metal form complexes, I will teach you in my future videos. In complexes, normally central metal atom come from transition element like iron, copper, anything like all the most of the d block element, they form the complexes. In case of the complexes, the ligand donate a pair of electron to central metal cation, which is a transition metal, and they also form a dative bond. That's the dative bond. Dative bond, it's a kind of back donation, or it's a type of a covalent bond in which one of the bonded atoms donating shared pair of electron. Okay, guys, can we do one question? Okay, I will give you one example. You have to predict the bonding present in that compound. See, mostly dative covalent compounds form Ionic bonding. Quite surprising. Yes, because they form ions. Hydronium ion, ammonium ion. And they also participating in making ionic bond. Let's do one question, guys. Predict the type of chemical bond present in ammonium chloride. Any guesses? First, let's start with ammonia. Ammonia, NH3, covalent. Ammonia make ammonium ion. Just now we have done with the help of a dative bond. This is dative or coordinate covalent. Ammonium ion, NH4 plus. The plus charge is not on the hydrogen, it's overall. Combine with Cl minus and make ammonium chloride, which has ionic bonding. So it has all three, guys. I like this example. This example has all the three different types of bonding: covalent, dative, and ionic. And the last type of bonding is metallic. I will teach you the metallic bonding. I know that. I will make a video on the metallic bonding. After that, I'm going to start shape of the molecules, or I'm thinking either the shape of the molecule or the intermolecular force of attraction. That's hydrogen bonding, permanent dipole, or induced dipole. Okay, guys. Thanks for watching my